last question then is about phenylamine. This one there's lots of explaining to do. So it's one of those tricky questions where it's not enough to know what goes on, you've got to be able to kind of say why, and that's really important. So first of all, it tells us that phenylamine is liquid at room temperature, slightly soluble in water. Why is it only slightly soluble in water? That needs commenting on, because although the NH2 group can form hydrogen bonds to water, that's favourable, that will tend to encourage dissolving. This part of the molecule, the phenyl ring, is large and it's non-polar, and that can't form hydrogen bonds, so it will be unfavourable to dissolve that. So that's why it's only slightly soluble, because of the large non-polar phenyl group. But it does dissolve to an extent, and you get a pH of about 9. In other words, you get a slightly alkaline solution, and you need to write an equation to explain why the solution is slightly alkaline. So the key, remember, is that like all amines, phenylamine has a lone pair on the nitrogen which it can use to pick up H+. In other words, it's a proton acceptor, it's a weak base. So if you add water, it can pick up H+ from the water, and that leaves behind OH-, so you get this reaction. It forms a phenylammonium ion, which is this, NH3+. Right, so it's grabbed the extra H+ from the water, become positively charged, and that leaves OH- behind. Okay, so if you write that equation down, that explains why you get an alkaline solution at about pH 9. Then, carrying on with the theme of phenylamine being a base, it tells you that when you add it to aqueous hydrochloric acid, it dissolves readily. And that's because, again, it can act as a base. So if you add an acid to it, plus HCl, you just get acid plus amine forms a salt. So it forms, let's draw it here, again the phenylammonium ion, and this time because you're adding hydrochloric acid, you'll get phenylammonium chloride as the salt that's formed. So that's the reaction. Again, that equation needs to be written down, but you then need to explain, first of all, why is that now much more soluble? And the answer is because this is made of ions, and so they can form ion dipole interactions with the water which are much stronger than the hydrogen bonds which this can form. So because these ion dipole forces that the salt can form are stronger, it makes it more soluble than the base, which can only form hydrogen bonds. The other difference, coming back to the beginning, it pointed out that phenylamine is a liquid, but that this compound, if you evaporate away the water, is a crystalline solid. Again, that comes down to the fact that this is ionic. So to melt this, you have to break ionic bonds, or you can even spell that out to be on the safe side. You have to break the strong electrostatic attractions between the ions. Because they're strong, that needs lots of energy, so it's actually still a solid at room temperature. To melt this, you don't have to break ionic bonds, you just have to break intermolecular forces. And because they're much weaker, you don't need so much energy, and therefore that's already happened, it's already liquid at room temperature. So make sure you spell it out. It's about the strength of the forces you have to break in order to melt it. Intermolecular forces here which are weak, but ionic bonds here which are stronger, so the melting point is much higher. And I think that's all there is to it. So quite a few things to explain there. Make sure you went through the whole thing and sort of highlighted, at least in your mind, all the things you had to comment on. But I think we've covered everything there, and that's the end of the paper.